Hello, ladies and gentlemen. It's Mike here at Game From Scratch, and today we've got one for the programmer. Specifically, if you're trying to add audio, either playback or capture to your game or application of choice, this is a cross-platform C library that is super simple to get started with. And this is MiniAudio. It is available at MiniAudio with a dot somewhere in the middle, so MiniAud.io, which is clever enough. As I mentioned, it is a single-file audio playback capture library. Basically, you just download MiniAudio.h, include it in your file, and you are good to go. So as I mentioned, single file only, capture written in C, written from scratch, no external dependencies with the exception of the C standard library and necessary platform-specific backends. It just works. You add it to your source tree and go. No need to dissolve any dependencies at all. It is cross-platform. It works on Windows, Mac OS, Linux, BSD, iOS, Android, and even the web via mscripting. And it is simple. It has a simple, flexible, low-level API that gets out of your way, just initialize the device and start sending audio data via callbacks. And it is free and open source up on GitHub. So we'll come back to some of the features of it in just a second. As I mentioned, it is an open source project. Interestingly enough, its license is under a version of MIT I have never actually heard of before. So where did the license descriptions go? Where are you? All right, yeah, here it is. So it's your choice of either being public domain, which is actually problematic. You always want to have some kind of a source code license attached, or the MIT no attribution license. If you're a regular to this channel, you know I'm a fan of the MIT license. It gives you just about any flexibility you want, but there's often an attribution clause. So if you do anything with the license, you got to have attribution in it. This is God. So it's even more permissive than the typical MIT license. So if you're interested, I will, of course, have the link to the GitHub page down below as well. So if you want to get in here, there's a decent amount of documentation and so on, all available right here. But as you're going to see, once again, a single .h file, and it even includes the documentation in that .h file. So if you want to go about using this, I do have to start things off with a prefix. This is a C library. I'm using one of their examples for this particular case. It is a C example. Now, I know in this day and age, so many of us like to think of C and C++ as interchangeable, but the C language has actually evolved and gone on a different tangent than C++. So they say they used to say C++ was a superset of C, but now keep in mind, they are separate programming languages with separate features. So what I've got to do here is a little bit of setup. Another thing here is this particular example expects that the second arg, argc2, is going to be the file name to go ahead and open. So I'm going to show you how to configure that at the same time. So if you're using Visual Studio and you want to compile this with C code, what you want to do is come into C++ and then go to Advanced and make sure that it's set as Compile as C in the Compile as category. Or you're going to have to port the C-ness to the C++. But this is not valid C++ code, this demo, the way things are done. So just something to be aware of. And then finally, in the debugging features here, all I've done is added command argument to the name of the WAV file that I've put in the same directory as the project. But otherwise, all you really want to do is download the include file, like so, add it into your project, and #include it to wherever it happens to be located, and you are good to go. So here is an example of MiniAudio in action. This one, again, opens up a file and plays it back. So we've got this data callback. As they said, everything here is done via callback. So this is reading in PCM or the WAV file frames in this particular case. So you can see a lot of this is around setting up device. So first we check to see that there is an input file passed in, that WAV file in this particular case. We decoder on it, make sure that that worked, and then mostly it's a matter, again, of setting up a device. So here we're saying initialize it, set it up for playback formats, the number of channels we want. Those were all defined earlier. So basically, what you're normally doing is like 44 kilohertz, 2 channels, the sample rates there. The callback is put in place, and so on. And then you're basically calling to initialize the device, and then to start the device. Since the device here in this particular case is to do playback, so you can see right here, device type playback. Your various different device types are available. See if I can get IntelliSense to show me them. Type. Yeah, so here you got capture, duplex, loopback, and playback. So those are your various different kind of, I don't know, you could consider that verbs, things that you can actually do here. So you can also use this library, for example. So this here is a simple playback. There's also other samples for doing things like playing a sine wave or capturing and recording from the mic, etc. And then finally, if it fails, So this is where the device is started. This is going to start actually playing back the sound file that we passed in. And then we just basically run until we hit the enter key, and then we are done. It doesn't like this because we don't actually do the record value or the return value, anything with it. And then finally, uninitialize the device, uninitialize the decoder, and you are done. So realistically, you're looking at about 10 lines of code to set up the audio device and to play some music on it. So this is one of the examples here. And then again, everything is in the .h file. You're going to notice here is the .h file, and this thing is I believe 2.5 megabytes in size. So everything is implemented here, but you'll even notice at the very beginning here, you've got complete documentation on how to actually go ahead and use this library. So you've got a lot of support for various different formats that are out there. We'll look at that in a second. And then you've got channel support here. So if you're supporting surround sound instead of just two channels, you can see the additional functionality there. So there is in-depth documentation all in this header file. And then we can just kind of keep going and going. I'm actually curious how many lines of code there are in this header file. Let's just go to the end. Yeah, 63,000. So the 63,000 lines of code here. Again, there is a ton of documentation in here. The release notes for all versions are in here. The license is in here and everything else. But again, it's a single header file. You want to add audio, so you can initialize your device. You can do playback. You can get various different encodings, and you can even do audio capture using this guy. Single header file, include it in your project, and you are off to the races. Pretty cool stuff. So let's go back over to here, and we basically, so there is a breakdown of one of the examples. I'm not sure which one they used. It looks like pretty much the same one I just showed. So this is for playing, for playing an audio file right there. There is full documentation available here. As you can see, the platforms, we covered this in the past. Most Linux is Mac OS, iOS, Windows, Universal Windows platform, including HTML5. It's got support for a number of different backends, such as Direct Sound, Core, ELSA, Jack, on and on it goes, plus web audio for end scripting, and you can even have a null backend if you so wish. Major features include the option of licensing there, including that MIT, even more liberal MIT license going on, contained in a single file, no external dependencies, written in C, compatible with C++, except for the examples in this particular case. I showed you how to compile those as C. Support all major desktop and mobile platforms with multiple backends for maximum compatibility. Support playback, capture, full duplex, and loopback. Device enumeration for connecting to specific devices, not just the defaults. Connect to multiple devices at once. Shared and exclusive mode on supported backends. Backend specific configuration options. Device capability querying. Automatic data conversion between your application and internal device. Sample format conversion with optional dithering. Channel conversion and channel mapping. Resampling with multiple support for multiple algorithms. We got a number of filters built in, including high pass and low pass filtering. Waveform generation is built in, including sine, square, triangle, and sawtooth waves. So if you want to do, again, sound done via waveform generation, you could do that right there. Noise generation, white, pink, and Brownian. You can decode WAV, FLAC, MP3, and OGG Vorbis via the STB Vorbis, which is not built in. It must be included separately. So that is your one dependency. If you want to do OGG files, you're going to have to use STB Vorbis as well. And it can encode in wave format. And that's basically it. The building instructions are a joke. Basically, pound include the downloaded .h file, and you are good to go, unless, of course, you want to get into using OGG Vorbis files, in which case you have a slightly bigger install process, but not really that much extra work there. And if C is not your language of choice, there are a couple of other language bindings out there, unofficial. There's Go, Python, and Rust language. Plus, being C-based library, you can generally just use it in almost every kind of programming language out there. That's the nicest thing about C. It is probably the most interop language that has ever been created. So that is it. That is the MiniAudio library. Ton of features on this guy, definitely worth checking out. Very straightforward. Now, the library itself is actually, it's not the simplest thing you've ever seen, but it is fully documented. So if you want to figure out how to do things, it's all in here. All the details are there, and it's a surprisingly capable library and framework for being a single file. Also, by the way, there is also instructions there. So if you want to split it into implementation and oh God, what are the words I'm looking for? If you want to split it into a .c and .h file, there are options there as well, and they are in the instructions if for some reason you don't want to just have a giant .h file. But well documented and well supported. It is updated quite frequently. So as you can see, there was a commit 7 days ago. It's been ongoing support for quite a while. I think the first release was 10 months ago. Definitely one to check out if you're looking to add audio to your C or C++ based project in a cross-platform manner. And once again, there are bindings there for Go, Rust, and Python if those are your weapons of choice. So anyways, that is MiniAudio. Let me know what you think, and I will talk to you all later. Goodbye.